All right, now we get to amp up the equations just a little bit. So we're going to do two things. We're going to solve a linear equation with fractions, and we're going to solve a linear equation with decimals. So this video is going to be on solving a linear equation with fractions. So I don't know if you remember, way back when we started solving linear equations, there was 4 steps. And step number 1, there was this little bit in italics that said clear any fractions and decimals. Well, here we go. So if you come to a question and it has fractions, you have the ability, now this is not mandatory, but you have the ability to get this equation to not have fractions. You can use the multiplication property of equality to say, hey, I'm allowed to multiply an equation by whatever I want, as long as what I do to one side I do to the other. Well, watch to see what happens when I multiply by the lowest common denominator. So let's first off determine what is the lowest common denominator. So I have a 4 and I have a 3, and then this is over a 1. So what's the lowest number that 4 and 3 and 1 all go into? It would be 12. So what I'm going to do is I'm going to multiply both sides of the equation by 12 because I'm using the multiplication property of equality. Now in reality, what that's going to do is multiply every term by 12. Okay, why would I want to do this? Well, let's look at this first term. This is, now you don't need to write this down. I'm going to write down what I actually do here. But this is 12 times 3/4. We can ignore the fact that there's an x there. It's just going to stay there. When you think about multiplying fractions, you can think of it as multiplying across. So you could end up with 36 over 1 times 4 is 4, which is 9. But there's a reason we chose 12. We chose 12 because it was a number that all of my denominators would go into. So instead of doing the multiply and then the divide, we could do the division first. We can go 12 divided by 4 is 3. Then I'm left with 3 times 3, which is 9. I get the same answer. So we're choosing a number that all of our denominators will divide evenly into so that we can get rid of our denominators. So when I look at this one, let's just change to a different color. I've got 12 divided by 4 is 3. I would be left with 3 times 3x. The denominator went away. For the next one, I have negative 12 divided by 3, which would be negative 4. I'd be left with negative 4 times x. Now for this one, it was a denominator of 1, so 12 divided by 1 is still 12, so I'm left with 10 times 12. I was able to rewrite this equation without any denominators. I've turned it into a simpler equation. Now I could distribute, I could multiply to simplify. So I'd get 9x minus 4x is equal to 120. Then I'm going to collect like terms. I would end up with 5x is equal to 120. And then to get x by itself, I'm going to divide each side by 5. And I would get x is equal to, I think it's 24, but because this is a video and I'm nervous about getting it wrong, 120 divided by 5 is 24. Perfect. I got my answer. So when you see an equation with fractions, most people choose to get rid of the fractions. How do you do it? Well, you can multiply by everything by 12 because then the denominators divide evenly in. This is not the only way, right? Some people like to create a common denominator of 12, and then once they're all over 12, you're like, okay, I've taken care of that part, and they can drop the denominator. Some people don't even care that there's fractions, and they just run with it. So they just add these, and then they'd have something to multiply by, something to divide by. But honestly, in all my years of teaching, this is what most people do. So if there's something else you want to do and you're not sure if it's correct, come and show it to me. I used to show videos where I'd show multiple methods, but it always annoys people. So I'm just going to make this one say, hey, this is what you're going to do. And you're all going to go, oh, wow, that's so great. Now, let's also, because it says and check, if a question on a test or for your learning assessment that you hand in says and check, make sure you check. So again, to check, you always check into the original. We're going to plug in x equals 24 into the original. So this is my check. Then I've got minus, I'm plugging in 24 for x here, over 3. Does that equal 10? So again, does left side equal to right side? I'm going to grab that calculator because I do not need to do this by hand, although I can. Okay, but it's really good to be able to use a calculator. This is 3 times 24 divided by 4 minus 24 divided by 3, which equals 10. Since left side is equal to right side, that means that 24 is my solution. Awesome. Let's try another one like that. So you can pause the video if you're feeling pretty good about this. You could pause the video and give this one a go, or you could just keep watching if you're feeling a little bit confused. So again, I have 3 terms here. I have a denominator of 5, a denominator of 4, and a denominator of 1. What would be my lowest common denominator? Well, they all go into 20. So that means I'm going to multiply both sides of the equation by 20. In reality, I'm going to show that I'm multiplying every term by 20. And it doesn't matter whether you do 20 times 1 or 1 times 20. Then why did we do this? Well, we did this because 20 divided by 5 is 4. Negative 20 divided by 4 is negative 5. That leaves me with 4 times x minus 5 times x is equal to 20. Then the distributing, this is really just 4x minus 5x is equal to 20. So I'm going to collect like terms. 4x minus 5x is negative 1x, but we don't write the 1. To get x by itself, I'm going to divide each side by that negative 1, or you could multiply both sides by negative 1, and you would end up with x is equal to negative 20. Again, this question said to check, so we are going to check it. Is negative 20 divided by 5 minus negative 20 divided by 4 equal to 1? You can do it by hand, or you're allowed to let your calculator do the work. So for me to plug in this one, I've got negative 20 divided by 5 minus negative 20 divided by 4. And my calculator is kind of fancy, so it does all sorts of weird things. Yours will look a little bit different. And I get 1. Well, yay! Left side equals right side, therefore my solution is negative 20. I did not need to state if it was an identity or a contradiction because I got a solution. X equals negative 20. This is conditional. The equation is true on the condition that x is equal to negative 20. All right, let's just do more. So I think I have 2 more examples. Sweet. Okay, 2 more examples and then just a quick concept check for this. So for here, again, I have 3 terms. This is 1 term, 2 terms, and 3 terms. When you look at this, I want you to see this one has a denominator of 1. What is the lowest common denominator? I have a 6, a 1, and a 3. They all go into 6. So I'm going to multiply both sides of the equation by 6. In reality, that's going to make me multiply every term on either side of the equation by 6. Why do I do this? I do this because the denominators are going to divide into them. I chose this number so that 6 divided by 6 is 1. This one doesn't have a denominator to divide. This one is 6 divided by 3 is 2. What am I left with? I'm left with 1 times x plus 11 minus 6 times 2 is 12. I'm just going to do it. And then 2 times 2x minus 5. Now I'm going to distribute, so I end up with 1 times x is 1x, 1 times 11 is 11, minus 12 is equal to 2 times 2x is 4x, 2 times negative 5 is negative 10. Now I have to make a decision. I mean, I could keep simplifying. Let's collect like terms. So I got x minus 1 is equal to 4x minus 10. Now I want to put my x's on one side and the numbers on the other. I'm going to isolate my variable term. I can either put my x's on the left or the right. I'm going to choose the right. So I'm going to minus x from each side. I end up with negative 1 is equal to 3x minus 10. Then I want to get the x term by itself, so I'm going to add 10 to each side. I end up with 9 is equal to 3x. And then I'm going to divide both sides by 3 to get x by itself. And I end up with x is equal to 3. Again, let's just keep this method of checking because these are hard. These are bigger, they're harder. So if I plug in x is 3, usually when I substitute in brackets. So it's 3 plus 11 divided by 6 minus 2. Does that equal 2 times 3 minus 5 divided by 3? And again, we're going to let our calculator do the work. You don't have to, but I don't want checks to be like this crazy labor-intensive process where you're going to make integer mistakes. So when you're plugging in a fraction, make sure you put the top in brackets. So I would have bracket 3 plus 11 unbracket being divided by 6, taking away 2. I end up with 0.3 repeating. Let's check the right-hand side. Again, my numerator is going to be in brackets. So this is 2 times 3 minus 5, unbracket, divided by, oh, where did the 5 go? Divided by 3. Oh, look, I also get 0.3 repeating. I'm good. Therefore, my solution is x is equal to 3. I do not need to state if it's an identity or a contradiction. All right, if you're feeling good, pause the video, try this last one. If not, keep watching. I'll do one more with you. So for this one, actually, this one's got a little thing. So let's see if you catch it. So for this one, lowest common denominator, a number that 6 and 4 both go into. You can choose 24, but that wouldn't be the lowest common denominator. So I would go multiples of 6. So 6, 12. Since 4 goes into 12, I'm going to pick 12. So I'm going to multiply both sides of the equation by 12. In practice, that's multiplying every term by 12. You'll notice I'm showing this work. I am the laziest person on the planet when it comes to math, and I always show this. If I don't, I always make a mistake. So I'm showing that I'm multiplying every single term by 12. Why am I doing this? Because now 12 divided by 6 is 2. Negative 12 divided by 6 is negative 2. 12 divided by 4 is 3. I am left with 2 times 5 minus 2 times 3 minus x is equal to 3 times x. I've turned it into a nice simple linear equation in one variable with no fractions. So now I'm going to simplify. 2 times 5 is 10, and then I'm going to distribute. So I get minus 6 plus 2x, be careful with your integers, is equal to 3x. Then I'm going to collect like terms. I end up with 4 plus 2x is equal to 3x. Now I'm going to put my x's on the right. So I'm going to take away this minus 2x term. So remember, you always add and subtract first. You end up with 4 is equal to x. Yay! Now again, let's just finish this with a check. If I plug in x is 4, I've got 5 divided by 6 minus 3 minus 4 divided by 6. Does that equal 4 divided by 4? Okay, well, I know the right-hand side is going to be a 1. Let's check the left-hand side. So I've got 5 divided by 6 minus bracket 3 minus 4 unbracket divided by 6, which also gives me 1. Yay, I didn't make any mess ups. So my solution is 4. Awesome. So that's the thing. Okay, that is the skill. So go and practice a million of these. Practice as many of these as you need to practice until you're feeling super confident with fractions. You'll notice when you go to do the homework that I actually assign some even questions too, because you just need lots of these. For some people, this is like mystifying. But I promise you, if you practice enough until they feel repetitive, it won't be too bad. Okay, but you really have to do enough. And again, I can't say enough. If this doesn't work for you, come and ask me. I've got 3 other methods I could show you. But this is the method I find most people end up doing and most people are successful with. But there's other versions of it. You can also look on YouTube too. There's lots of Khan Academy. They probably give you other options as well. But there's one thing I have to do to clear my conscience before we move on to the next thing, which is a concept check. Why were we allowed to get rid of the fractions? So, for example, what do I have written here? I have two things. What's this versus this? What do you notice is the difference between these two questions? Well, in this one, I've got a -3, and this one I put in an =3. This is an equation. This is an equation with fractions. This is an expression with fractions. My question to you is, if you have an expression with fractions, am I allowed to be like, hey, I don't like these fractions. I'm going to get rid of them. What I do to one side, I'm going to do to the other side. Uh-oh. An expression is not an equation. I'm allowed to look at this and go, hey, the lowest common denominator is 4. I'm going to multiply both sides of the equation by 4 because I'm keeping it equal. I could do this and I would get 4 times 1/4 x. Oops, that looks awful. Minus 4 times 1/2 x plus 4 times 3/2 is equal to 4 times 3. I'm allowed to do that because I'm keeping it equal. Left side still equals right side. I'm trying to find the value of x that's going to make this true. If I do that, I'm allowed to do 4 divided by 4 is 1. -4 divided by 2 is -2. 4 divided by 2 is 2. I'm left with 1 times 1x minus 2 times 1x plus 2 times 3 is equal to, well, 12. And then if I kept solving, I would end up with x minus 2x plus 6 is equal to 12. Combine my like terms, I get -x plus 6 is equal to 12. I want to get x by itself, so I'm going to subtract 6. Oh, my computer's thinking. Uh-oh, what just happened there? So I'm not quite sure where that video cut out. I think we were somewhere around here, right? So I had collected like terms. I get -x plus 6 is equal to 12, and then I had -6 from each side. I end up with -x is equal to 6, and then I would divide each side by -1 to get x by itself, and I would get x is equal to -6. I got a solution for x. When I plug in x is -6 into the original equation, it will make it true. Versus an expression. In an expression, you're not trying to find the value of x that's going to make it true. You're just trying to simplify the expression. So the only thing you'd be able to do is collect like terms. To be able to collect like terms, you'd have to create a common denominator. This is 1/4 x minus, I could make this a denominator of a quarter by multiplying by 2 over 2, which would end up as 2/4 x. And then here, this is 3 over 1. So I'm going to make it a denominator of 2. I would end up with 3/2 minus 6/2. So all I could do is say that 1/4 x minus 2/4 x would be -1/4 x. And then 3/2 minus 6/2 would be -3/2, which would, whoops, that's not halves, that's 6. And then that's it. That would be my simplified expression. There's no value of x that's making it true. So I wasn't allowed to get rid of my fractions because I wasn't just trying to make it into another form to solve for x. I was just simplifying. So you're only allowed to get rid of a fraction when you have an equation. Why? Because you're keeping it equal even if you multiply both sides by the lowest common denominator. Whereas with an expression, you don't have sides. So all you can do is collect like terms, distribute, simplify, do all of those things. So just be thankful when it's an equation with fractions, because if it's an expression with fractions, you're stuck with them. Awesome. Good luck.